Welcome to TutorialsArc, your go-to destination for unraveling the fascinating world of computer science and information technology. Whether you're grappling with complex concepts, seeking clarity on industry jargon, or eager to explore the latest emerging trends, you've come to the right place. We break down intricate topics into easy-to-understand explanations, making learning accessible and engaging for everyone. So, buckle up and get ready to expand your knowledge in the ever-evolving digital landscape. TutorialsArc, optimized for learners.
Linux operating systems. Yes, the Linux operating system is known for its relatively high security, like its counterparts, the Unix operating system family. And one implementation that enables this is the file permissions. In this video, we'd like to give special attention to permissions in Linux operating systems. It says that everything is a file. This fundamental concept, means that everything ranging from regular documents, images, programs are all treated as files and directories. In fact, even hardware devices, inter-process communication mechanisms are represented as files within the file system. So what we want to focus specifically on today is what these file permissions are and how they are implemented. So in the short video, we want to see how we can write a script using a text editor. Of course, while we bring this in, we want to see how the use of these permissions can affect the day-to-day tasks undertaken by the Linux operating systems. We shall run the script to see how these permissions affect the procedure. We then explain the permissions using the ls-l utility. Of course, there to gives us quite a number of fields, but our focus will be mainly on understanding what these permissions are. We shall then go ahead and explain how these permissions are granted. There's an aspect that is involved here where many of us or many of the readers will want just to memorize numbers and implement or grant these permissions. But a good understanding provides a nice foundation to working with the Linux operating system. As we have seen, everything is a file. To start with, let's go right away to our terminal, the Linux terminal. So now on our terminal, we want to see how we can play about this file, create a file using a text editor of our choice, and then assign permissions. So for this case, let's clear our screen. We can take, for example, Nano. Nano is a text editor that allows us to work with text or documents as others may know it in Linux environments. So let's use Nano. We know there are other options like VI, like Vim, but Nano is quite user-friendly, like Vim also quite user-friendly. VI needs someone who understands what he is doing. So we have Nano, and then let's call it students with the S. Then give it that extension so that it is considered a script. We shall later on run the script. So nano students.sh, click enter, and that's the text editor. But now for purposes of appreciating the effect of these permissions on tasks that are performed on Linux, we are going to write a script. So to write a script, there is always that signature first line that shows the shell that we're going to use. However, do not be scared about this. It's just an example to put it. We shall later on see what the scripts are. So let's type that line. It is hash, that's called the shebang / identify the location of the shell that is being used. So let's take bash. Then we write a text, any text on our document or on our file. I'll say this is tutorials arc script. But remember, the purpose of writing scripts is to list commands, and then these are automatically executed. If something is not a command, then we can instruct the script not to run it. So like this line is not a command, we put a comment. So that comment means that line is not going to be executed. Then we could add another line here. Run this script to find a list of files. So we are going to put a command. In this case, we're not commenting on it. That command is supposed to display for us the number of files, the different files that are contained on our system. So we shall say ls, use the ls utility that lists that command, and put that -l to put it in vertical format. So we have written our script, simple script there. We need to save it. So the using this text editor, the options right down here, shortcuts on how we can save. So our issue here now is to write out or to save our information or our file. So I'll say write that combination Ctrl-O on your keyboard. Yes, then exit that, right Ctrl-O, and then accept the file name. In this case, says by default students.sh. I'll click enter to accept, and then we say exit. To exit will be a combination of Ctrl and X. So I'll say Ctrl X, and it exits. So how do our permissions work here? If we had the permission, then running these scripts would automatically be possible. So how do we run a script? If I say dot, that means I'm running that script from the current directory. What was the name of our script? It was students. It was students.sh, not student. So did we assign the user permission to run this script? No, we didn't. So what do we expect if someone clicks enter to run? That's what we expect, permission denied. So that takes us back to the different ways in which we assign this permission. But before we look at that, let's just have a visual view these permissions using the normal utility ls-l. That will give us the different permissions assigned. Do you remember our file? Our file was students, not student. So we take students, that, and what is the permissions assigned? What are the permissions assigned? If we look at this first character, it shows us it's a file. If it was not a file, if say it was a directory, we would have a D here and other types of files. For our case in point now, we want to work with the file. That's why we have a dash. After that dash, we have consecutive spaces, 9 digits here, that represent permissions assigned to the different users. So what are the different permissions that we can assign in Linux? We can give someone permission to read as represented by letter R, permission to write represented by W, and permission to execute represented by X. So these first 3 spaces normally is for the user, me, the owner who's creating the file, who's working with the script. So what permission does he have? He has permission to read, I have permission to write, but a dash, no permission to execute. Then what about the next 3? The next 3 is for the group. In Linux, we have many users. So these many users could be categorized depending on possibly their responsibility in an organization. So we can assign this group at once instead of individual assigning each of them. That's what the group is meant for. So the group, in this case, the default group, is given a read permission. Does it have the write permission? No. Does it have execute permission? No. It only has the read. And then others who are not part of the user, neither are they part of the group. So for them, they only have the read also, no write, no execute permission. So those are the permissions. But now we are back to me who was working with my file. I need to assign myself the execute permission so that I run the script. And that's why we said there are two ways of assigning these permissions. Let's go back to our slide and review those permissions that were just mentioned earlier. So at this point, we want to appreciate how these permissions can be granted. There are mainly two major ways how it's done. As shown in our slide, number one is we can use the symbolic mode. This uses letters to represent the users, represent the group, and then represent the others, as we've just explained in our terminal. So in this case, we use the plus sign to add permission, we use a minus sign to remove permission, and we can use the equal sign to set the permission. So we could set our permission to R for read, to W for write, and X to execute. So could you say our example, change mode U plus X? In this case, it will add the execute permission to the file that we're going to specify. In this case, it is file.sh. So let's move and see how this is done. Let's now assign this permission. Remember the two techniques, we're going to use the first method. That's by use of symbols. Use those letters. How do we do it? We use the change mode. Take note, it's not change mode with E, it's a change mode. But then we are adding permission to who? To the user. U for the user and add permission. What are we adding? We want him to have the execute permission. On what? On the specific file. What is the file? The file is student.sh. So the user should be having that execute permission if this command is right. So we say enter and it has accepted. Let's revisit again, use our ls to see the permission that the user has. Go back our ls space -l and press enter. Our file, remember, was students, not student. If we take note, it remains of course a dash for the file. That was method number one. In method number two, that's what we want to move to now. Numeric mode, or one would call it the octo mode. This approach uses a 3-digit number, each digit representing permission for, again, either the owner, the group, or the others. It is known that if we want to read, then the number will be a 4. A write permission is a 2, and execute permission is a 1. Then these values are added. For example, we say change mode or ch mode 755. It will give the owner the read, write, and execute permission. When we add that, we get 7. The group and others read and execute permission, which is 4 plus 5. Remember, 4 was the read permission and the 1 was execute permission. So we add the 4 plus 5 plus 1, and get a 5. Hence, change mode 755. But now what we are trying to say is we need to understand how these numbers come about. And this is what we want to explain. We want to go back to our terminal and see how these numbers come about so that whenever we use them, we really understand what they represent. So again, let's go back to the terminal. So in this case, let's clear our screen. And then just for purposes of comparing, Let's put our ls command to see the permissions that are already granted. So we know our file of interest is line number 2, that's students.sh. But there's a related file, also students, let's not confuse them. So we have students.sh. In this case, our user has already been granted full permission, but then the group has only read permission, no write, no execute. That's exactly what we want to modify. So let's go back to the file, that is students.sh. Our text editor we use now is nano students.sh, nano students.sh. So again, let's type after that. Let's just push this down, and in between here we add a comment. This section is to help us appreciate how these numbers come about, 7, 5, and so on. So if a user is to be granted permission, he is going to be granted either the permission to write, permission to read, or could put it the other way around, read, write, or execute. So if we add our comment here, if he has the permission to read, we want to take that as either switched on or switched off. If it is on, then he has that privilege or that permission. So assuming he has the read permission, so we shall have read, then no write and no execute. So we have a dash, meaning no write, a dash, no execute. What is that in number format using decimal? So what normally we do, we want to take each of that read for a 1 since it is on, the write permission is 0 since it is off, and the execute permission is 0 since it is also off. If we convert that to decimal, what do we get? It will be 2 power 0 times 0 plus 2 power 1 times 0 plus 2 power 2 times 1, which will give us a 4. So the permission to read without any of the other is number 4. What about permission to read, write, but no executing? Again, what does that mean? A 1 for read since it is on, a 1 for write since it is on, and off for execute, 0. So similarly, we have to convert that to decimal. That will be 2 power 0 times 0, 2 power 1 times 1, which is a 2, plus 2 power 2 times 1, which is a 4. So this will give us the number 6. Yeah, we can try this conversion method examples to be conversant without convert decimal to binary and binary back to decimal. If we go to, we assume we give them full permission. So it means there's a read, there's a write, and execute. So it is 1 on for read, which is a 1. There's on for write, which is a 1, and on for execute, which is a 1. Again, we are starting from the right going backwards to the left. So we shall have 2 power 0 times 1, which is a 1. 2 power 0, which is a 1, plus 2 power 1 times 1, which is a 2, plus 2 power 2 times 1, which is a 4. So this is equal to 7. And that's why whenever they say is given full permission, you are going to get the number 7. So these are how the numbers come about. So we want to save our script. We have appreciated how numbers come about and see how these can be assigned. We go back, do our Control O to write, accept the same name, and then exit. Control X to exit. Remember our file there, the group has no read permission, no write permission. Sorry, it has the read permission, no write, and no execute. So what we intend to do is give them full permission using those numbers. But now, if we are to assign these permissions, we have to specify the permissions for write, for the group, for the user, and for the others, all at the same time. So we want to assign each of these groups full permission. We use our change mod. Remember, without the E, then we don't use symbols, we use numbers. So for the user, whom I'm calling the owner, we shall give a 7. What about for the group? We want them to have full permission too, which we shall also call 7. What about the others? They will also have 7. But this is being assigned to students.sh. So we're saying change mode 777 to the file students, not student, but students.sh, and then we click enter. So that is change mode 777 students.sh, and it has accepted. So what do we do? Let's confirm whether those permissions have been granted. We use our command, the simple command -L, and then press enter. Let's go back to our file students.sh. Can you notice the change there? It's a file. All of them have rwx, rwx, and rwx. So using numbers, we can assign permissions to the different users of our file in Linux operating systems. Back to our slides. As we conclude, we've seen 2 ways of granting permissions in Linux, permissions to files. The 2 main ways that we have described are the numeric mode and symbolic mode approaches. In numeric mode, we saw that we used numbers such as 7 for full permission, we had 5, we have 1, and so on. The other approach uses letters. The letters had U for the owner, G for the group, and then O for the others. In addition, we also saw that Linux treats everything, so to say, as a file. This unified approach simplifies how these operating systems, that's the Linux operating systems, interacts with different resources within the system. In our next video, we shall appreciate other aspects of security on Linux operating system. See you in the next video.
Thank you for watching. We hope you found this helpful. We are always looking to improve, so please leave any positive criticism or suggestions for future videos. Are there any other topics, concepts, or terminologies you'd like us to cover in future videos? Let us know. And don't forget to subscribe for updates on new tutorials.